Hi everybody, welcome back. On your notes today, you're going to see that there's a box on the top here because what we're doing today are special cases. These are ones that you can easily see shortcuts in. However, instead of teaching you the shortcuts in the beginning, what we're going to do is we're going to show you how to tackle the problems. So then if you can discover the shortcut, it's more meaningful to you and you'll be more likely to remember it. So we're actually going to skip everything in this first part and we're going to go straight to our examples. Keep in mind, every single problem that we've factored and done the x factor with, we've had it in the form of ax squared plus bx plus c. This middle term b is missing from all these equations. We have a squared term and we have some constant at the end, but what we don't have is a middle. So to tackle these problems, we do it the same way as we did everything else. You start with your x. You multiply the first times the last. So in this case, you're multiplying the two numbers together. You get a negative 9x squared. Because there's nothing in the middle, we show that we have 0 x's in the middle. So what we're looking for are factors of 9 that when you multiply, you get a negative, and when you add them up, you get nothing. Well, the only ways to get 9 are 1 and 9 and 3 and 3. So if we look at that 3 and 3, in order to get a negative 9, one of those have to be negative. So we have a negative 3x and we have a positive 3x. By looking at those two together, they'll multiply to get us that negative 9x squared. And if you add them, they eliminate it. They cancel each other out. You get 0 x's. So then when I go through and write this out, I get my x squared minus 3x plus 3x minus 9. From there, I'm going to divide the problem in half, and I'm going to conquer it and divide. So looking at the first half, what do x squared and negative 3x have in common? You guessed it, they have an x. So when you take that x out front, what's left over? Well, x squared divided by x is just x. Negative 3x divided by x is negative 3. Now we go to the second half. Don't forget that sign, that's triply important. We write it 1, 2, and 3 times. And what can I divide both 3 and 9 by? Great job. You can divide them both by 3. So that 3 comes out front and then we divide. 3x divided by 3 gives me my 1x. Negative 9 divided by 3 gives me a negative 3. So when you look here, the parenthesis that duplicates is that x minus 3. And the one left over is x plus 3. And I have my final answer. Let's look at another one. Let's look at number 2. So again, I'm going to multiply first times last and put that at the top of my x. B squared times 81 is a negative 81b squared. How many x's do I have in the middle? I have 0 x's in the middle. So now I'm going to go through and look at all the factors of 81. So ways to get 81. I have 1 and 81. I have 3 and 27. And finally, I have 9 and 9. I'm looking for the special pair right here because when I do a positive and a negative of the exact same, they cancel out. So now I'm going to rewrite my equation with my b squared. I have a positive 9x and a negative 9x, and then I have a negative 81. Now that I have 4 terms, I can group it up. So divide, conquer, do your underline squiggles. Oh, sorry, those ones should be b's, shouldn't they? Sorry about that. There's your b's. Okay, so now when I look at my b's, b squared and 9b both have a b in common, so that b comes out front. What's left over? B squared divided by b is just b. 9b divided by b is a positive 9. Ooh, we have a negative sign. We write it 1, 2, and 3 times. 9b and 81, what can we divide them both by? A 9. So when I do that, I'm left with b plus 9 in parentheses. So my parentheses match. My first one is b minus 9. My second one is b plus 9. So let's look at those numbers a little more closely. 9 and 81 are special numbers. Those ones are perfect squares. If you were to type in your calculator, ignoring the 9 for a minute, do the square root of a positive 9, you would get 3, and those are your 2 wings of your x. If you look at the 81, if you enter the square root of 81 in your calculator, you would get 9. And again, the 9s are my wings. So you're kind of beginning to see a little pattern here. Let's go ahead and go on to one more. Let's look at letter D. So with letter D, again, we're going to start by doing our x. We multiply first times last. When you do 9x squared times a negative 16, what do you come up with? Keep working on it. You might have to type it in your calculator. Good. You should come up with a negative 144x squared. Now, 144 is a very large number. We know that there's a trick here. The trick that we know is if I'm missing my middle term here, I should double check to see if that 144 is a perfect square. So in your calculators, if you go through and do the square root of 144, what do we come up with? 12. So I have a positive 12x and a negative 12x. And if I add those together, I get my 0 x's in the middle. So now I can go through and do my 9x squared plus 12x minus 12x minus 16. I'm going to conquer and divide, so underline squiggle, and see what each part has in common. So 9x squared and 12x both have, good, they both have a 3x. When I take that 3x and throw it out front, what's left over? 9 divided by 3 is 3. X squared over x is x. 12 divided by 3 is a positive 4, and there's no x's left. Got a negative 1, 2, and 3 times. What do 12 and 16 have in common? Awesome job. They have a 4 in common. So when I divide them by 4, negative 12 over negative 4 is a positive 3x. Negative 16 over negative 4 is a positive 4. So my parentheses duplicate 3x plus 4, and my outsiders are 3x minus 4. And that's my final answer. Now, those of you that like to look for little shortcuts, you might see something here. If you look back at my original problem, 9 and 16 are perfect squares. If you're not sure what perfect squares are, well, 1 squared is 1. 2 squared, 2 times 2 is 4. 3 squared, so 3 times 3 is 9. 4 squared, so 4 times 4 is 16. 5 squared, which is 5 times 5 is 25. Those are all perfect squares, and it goes on for a very long time. So if you look, the 9 and the 16 are perfect squares, meaning if I enter that in my calculator, I get a positive, square root of 9 is my 3. Notice they both start with a 3. The square root of 16 is 4, so I have one positive, one negative to get me that minus 16 that I have there. So that's another way of looking at it if you're looking for shortcuts. Okay, so let's go ahead and go back to that box now. So if we look at this box here, it says you want to identify the squared number in each term. So what number squared? Technically, x is x times x, and 16 is 4 times 4. And then what we want to do is we want to write the square root of the first term in the first part of both parentheses. So let me put this in green here. The square root of x squared is x. So I'm going to write it here and here. Because there's no imaginary number in front, I'm just going to put a 1 with it. Now, looking at the 16, what is the square root of 16? Well, the square root of 16 is 4. There's my 4s. Remember, I wrote those 1s from before. And then what you have to remember, to get the negative, we need 1 positive and 1 negative. Following that shortcut way again, we can actually apply that to letter C. So looking at letter C, I know I need to get 2 parentheses. What's the square root of x squared? Well, it's x and x. What is the square root of 25? 5 and 5, but I need 1 positive and 1 negative. See how easy that is? But hold on a minute. Is this 25 negative? No, it's not. So this one right here is very, very special. It's our trick problem. You can't do it. Remember, we said, Can't do it. We said that this number right here needs to be a negative, and it's not. When it's not a negative, it's not factorable. You can't do it. That is a trick. Don't let anybody trick you. Has to be a minus sign. Awesome job. Let's just look at the back of the notes for 1 second. These ones are considered special cases, but let me tell you a little secret. There's nothing that special about them. Let's look at letter C, because I think this is a fantastic one. They call this one a special case because when you multiply first times last, so first times last, top of your x, you get a 4x squared. Your middle number is negative 4x. It's special because my top number is a perfect square. That's what makes it so special, perfect square. So what is the square root of 4? Great, it's 2. So you have a 2x and a 2x. But the deal is they have to multiply to be a positive, but add up to be a negative. So both of these are negative. That's really the only thing that makes these problems special. The rest of it all remains the same. So 4x squared minus 2x minus 2x plus 1. Now that I have that written out, I can conquer and divide and do my underlined squiggle. What do 4x squared and 2x both have in common? Good. They both have a 2x. So that 2x comes out front, and what's left over? Well, 4 divided by 2 is 2. X squared over x is x. All right, negative 2 divided by 2 is a negative 1, and my x's cancel. On the second half, I have a negative 1, 2, 3 times written. What do 2 and 1 have in common? Just the lonely 1. So there's my 1, and I divide. Negative 2 divided by negative 1 is a positive 2 with my x. 1 divided by negative 1 is a negative 1. What makes this answer so special is the one that duplicates is 2x minus 1. All of my outsiders is also 2x minus 1. We could rewrite this as 2x minus 1 entire quantity squared. That's why this one is special. Our parentheses will match completely. Great job today. If you have any questions at all, feel free to ask your teacher. Otherwise, I feel like you have the skills necessary in order to go on and complete today's classwork. Thanks again. I'll talk to you all soon. Bye.